Hello there, college algebra students. This is Mr. Kashi speaking. With this video, what we're going to be doing is we're going to be talking about a couple of things. One is going to be defining what a matrix identity is, and then how we're going to use it in a couple of different situations. Today we're going to be just using it to find whether two matrices are inverses of each other. So there's a lot of things in math that are pretty much the same throughout a bunch of different subjects. So what a matrix identity is just basically it's a square matrix that has ones in the diagonal. And what that means is, like, if we what that means is basically if we had what we call I2 is we just have ones like this, and then it's zeros everywhere else. And then if we had a 3 by 3 square matrix, we'd call that I3. You have 1, 1, 1, and then you'd have zeros here, right? And then so on and so forth. You go I4, I5, I6. The important things are that it is square and that ones are in the diagonal. And the reason that we have this is everything in math, when we're talking about numbers, always has an identity. So we don't really talk about these in great length in any of our math courses, but we have like identity, like an additive identity. So basically, what do I have to add to 5 to get 5 again? Well, I add 0 to 5 to get 5 again. Same thing with multiplication. What do I have to multiply 5 by to get 5 again? Well, in that case, I have to multiply by 1 to get 5 again. So now what we're talking about is, okay, if I had a matrix like 1, 2, 3, 4, what would I have to multiply that by to get that same thing again? Well, it turns out you multiply it by the identity matrix like this to get that same thing again. Just like that. So that's what an identity matrix is. Now, we use it in many different circumstances. Today we're talking about inverses, and really all we're going to be doing is taking two inverses and finding out if they are inverses of each other. So we have something like this. This is the inverse identity, or the inverse definition. So we have to multiply A times B, and we have to multiply by B times A, and they both have to be the identity matrix. And in this case, we're talking about I2, so our answers need to be looking like that. So this is takes a little bit of time. It's interesting enough that to find out if it is an inverse, you're going to have to go through the whole thing to make sure that it turns out to be the identity matrix. But if it's not an inverse, as soon as we don't get a 1 or a 0 in those specific spots, we can say, hey, it's not going to be an inverse. So we'll go through a couple examples here and go through those types of situations. So here we're going to do A times B. And so I'm going to go across the top here, and then I'm going to go down this first column. So we would have negative 3 times 1 plus 2 times 2. And like I talked about before, as soon as, so if this first term wouldn't be 1, we would be done, and we'd say, hey, it's not these aren't inverses of each other. So what I like to do right away is I'd like to go through and just go, okay, negative 3 and 4, right? And so, like, maybe I'd have this, and we know that's a 1 already. Okay, and so then I'll go across here, because we have negative 3 plus 4, we get the 1. We'll go across there, and then we're going to go down this second column. So we have negative 3 times negative 2 plus 2 times negative 3. And so this would be a negative 6 plus 6, and sure enough, that's 0. Down here in the bottom, we're going to go across, but we're going to go down this first column, so we have negative 2 times 1 plus 1 times 2. So that'd be negative 2 plus 2, sure enough, that's 0. And then we're going to go across here, and then down this last column. So we have negative 2 times negative 2 plus 1 times negative 3. And so that would be a 4 plus negative 3, and that'd be a 1. Okay, so as far as A times B is concerned, that is an inverse. But remember, so basically what we can do is we can say, okay, A times B checks out. Now we have to flip it around, do B times A to see if that checks out as well. So I'm going to do that on a separate sheet here. Okay, and I like writing this, the B matrix again over here. 1, negative 2, 2, negative 3. Just because I like having to go across here and down here. It just keeps everything organized. So this is going to be B times A. And so here we would have 1 times negative 3 plus negative 2 times negative 2. And so this would be a negative 3 plus 4, which we'll probably put the matrix down here. So that's a 1. Go across the top here and then down that column. So we would have 1 times 2 plus negative 2 times 1. So that'd be 2 plus negative 2, and we get a 0 there. Going to go across the bottom here, down the first column. So this would be 2 times negative 3 plus negative 3 times negative 2. So that would be a negative 6 plus 6, and that would be 0. And then the last one, we're going to go across, and then across the bottom, and then down the last column. So this would be 2 times 2 plus negative 3 times 1. So that would be 4 plus a negative 1, and sure enough, that would be a 1, which means that our B times A is an inverse. So that would be basically, we're just asking, is this are these two inverses of each other or not? And our answer would be yes. So just multiplying 2 by 2 matrices, and in this case, it turns out that both of them create the identity, the I2 identity, which makes this an inverse. So I want to move on to another example. I want to kind of just prove a point of what I've been talking about here. So here we have to make sure that A times B and B times A equal I2 in this case. Okay, they need to equal this right here. Okay, and so we'll start off with A times B, but what I want to make sure that you're aware of is that there's a reason I went through and did all of these operations as we were doing them. Okay, so here we go across the row and down the column. We have negative 5 times 4 plus 3 times 6. Well, the reason I do these operations right away is that this is going to be a negative 20, and that's going to be an 18, which means that we're going to get a negative 2 up here. So now I don't even need to go because negative 2 is not 1. I already know that these are not going to be inverses. So finding an inverse takes quite a while because you have to make sure that they all check out. But as soon as one of these is not the number it should be, in this case it's supposed to be 1, it turned out to be negative 2, we already know it's not going to be an inverse. So we don't have to go through A times B the whole time. We don't have to do B times A. It's one of those things that the correct answer, or I shouldn't say the correct answer, to find an inverse takes a really long time. But as soon as one of these numbers doesn't check out, you can say that it's not an inverse. So this tends to get a bad rap for being really long problems, but as long as you go through and do it like this, you'll find out those ones that aren't inverses rather quickly. So hopefully these examples were helpful, and I will always be available if you have any questions.